Hey guys, we're the Synbiohub DB-Link plugin group, formerly known as RoadSign, and this is our project.
The goal of this project is to connect Synbiohub to GenBank and Uniprot through the use of plugins. By being able to accurately relay parts among databases would allow for more efficient design-oriented research. We implemented this by using two plugins. And this project was proposed by Professor Chris Mayers at the University of Colorado Boulder.
And here's our demo video with both plugins. So here's what a page on Synbiohub would look like. Just looking at a green fluorescent protein. So scrolling down to the Uniprot plugin, you can see that it gives a drop down here. I can choose among up to 15 different matched parts. Each of them has this accession ID, which if I click, will take me to the corresponding Uniprot page. My internet's being a little slow, so I'll let that load. Meanwhile, you can also see that it links to different cross-reference databases. So this is, in this case, it has a GenBank one, and then this is a protein model database, just to show you that page just loaded. Again, I can link out to these guys, and it'll also show you an image of the model, if there is one. This is the case for most of them. And yeah, these are those cross-linked databases. And now going down to here, this is the GenBank plugin. This allows you to sift between up to 10 different results, and it also allows you to filter results based on these two metrics, the query coverage and identity coverage. So if I were to specify 100 here, you'll see, and then click filter, you'll see that now not all the results are showing, only the ones that have identity 100. And I can always reset that, and it'll go back. If I were to check this, then it would show nothing because none of them have both hundreds, but if any did, then it would show any that did. Right here, it shows the link to the actual GenBank page, and then the authors to different pages. Some of them have more authors, some of them don't, so that's why we have this drop down here. And here's that page I clicked. And so if we go over to here, you'll see that this one has multiple publications. This is just a different part. It's not a protein, which is why Uniprot doesn't load, but it has a bunch of different references, and you can kind of sift through those, look at some useful information. And all of the metrics that we've decided to display have been upon the request of Jet, the PhD student we're working with.
We will now discuss the Uniprot plugin. The Uniprot plugin consists of four main components: the plugin server, Uniprot Java API, Uniprot Protein REST API, and HTML and JavaScript. We will begin with the plugin server. The plugin server is interfaced with through three endpoints: the get endpoint status, which checks whether the plugin is running; the post endpoint evaluate, which determines whether the plugin is applicable to the Synbiohub page currently being viewed. For our purposes, we only want to interact with component type pages. If this condition is satisfied, the plugin will proceed to the post endpoint run. Here, the SBOL file detailing the component displayed on the Synbiohub page is retrieved, and the necessary operations are performed before submitting to the HTML page. Next is the Java API. As Uniprot requires protein sequences rather than nucleotide sequences, we must first convert the sequence retrieved from the SBOL file using BioPython. Then, the Java file which performs the API query is compiled and run. Within the Java document, the blast is performed, and the accessions of the first 15 or fewer hits are retrieved and written to a .txt file. We will now discuss the RESTful API. After the accessions are retrieved by the Python file, they are individually submitted to the Protein REST API. A JSON object is returned, and the desired information is parsed into a new JSON object for submission to the HTML page.
Now we can talk about the HTML and JavaScript side of the Uniprot plugin. Looking at the JavaScript side of things, it starts by checking if the Uniprot blast results were a success. Upon a success, it loads the drop-down menu, and then it loads the table. When it loads the drop-down menu, it iterates through the filtered data, and it appends the accession ID to the drop-down menu. When it loads the table, It searches through the data and it finds which accession ID matches the accession ID that was just clicked on. When it finds a match, it walks through the data for that accession ID and populates the text fields and the cross-reference database. And if there's a structural model, it updates that as well.
Now I'll talk about some of the features to the GenBank plugin. So here's an overall diagram. There's 4 main components: the plugin server, communication server, and database server, which make up the backend, and the HTML/JavaScript, which makes up the front end. In terms of the GenBank plugin server, it's very similar to the UniProt plugin server, except in the run endpoint between lines 62 and 66, I instead get the FASTA file and then send that over to the communication server. The communication server has 3 main API endpoints. The plugin request endpoint is where the plugin server can send the FASTA data to the communication server and receive back a unique query ID, as well as send the database nodes the FASTA file. The node data endpoint is used by the database server to send back the results to the communication server. And lastly, the plugin pull method is used by the JavaScript to check if the results are ready to be read.
Now we can take a look at the database nodes on the AWS cluster. On each node, there's a Flask API server that receives queries from the entry point node. When it receives a query, it starts up a thread and starts a Docker container. When it starts a Docker container, it mounts the local database fragment, and then it mounts the results directory to retrieve later. When the Docker container is completed, it searches through the results, and then it sends the results back to the entry point server. Now we can jump into the HTML and JavaScript end of the GenBank plugin. In the JavaScript, we have functions for loading the tables, the data table, and loading the drop-down menu. Additionally, we have an onReady function call. In the onReady function call, every 2 seconds, it queries the entry point node and checks if the data is ready to be retrieved. If it's ready, it loads the data locally and then initially populates the drop-down menu in the table. So we face 2 main challenges when making this project. The first is that the GenBank Blast API can take over 30 minutes for 1 query. We overcame this by fragmenting the Blast nucleotide database among many AWS instances and then querying them all in parallel to speed up the query search. The second challenge was that UniProt Java API enters a debugging protocol whenever the function getEntry is used. This issue is circumvented by taking only the accessions and querying these through the Protein REST API.
Regarding the future of this project, we are currently in conversation with the Myers Lab about officially adding these plugins to Synbiohub, and it is possible that the functionality of these plugins may be integrated as an inbuilt feature in future versions of Synbiohub.